So let's take a look at an example of using the aggregation framework to answer some questions about our data. Let's find out how we could use the aggregation framework to determine which user in our dataset has produced the most tweets. Now, let's talk about the process we would like the database to perform for us. So given the way our data is laid out, the first thing we're going to want to do is group the tweets by user. Remember, each tweet has the user as a field within it. Then we're going to want to count each user's tweets. And finally, select the user with the most tweets. Now, let's rethink this third step. What's probably going to be most valuable is not just seeing the one person who's tweeted the most, but instead counting the number of tweets for each user and then sorting them. If we sort into descending order, the person at the top will be the one with the most tweets. So our process is really group all tweets by user, count each user's tweets, sort into descending order, and then select the user at the top. Okay, so with this process outlined, let's take a look at how we would express this in the aggregation framework. And we'll use this as an example to launch our exploration of the aggregation framework in MongoDB. Okay, so aggregation queries in MongoDB are issued using the aggregate command. And we'll talk about this in just a bit, but aggregations are done with a pipeline. And a pipeline is essentially a series of stages that are included as elements of an array that's passed to aggregate as a parameter. Okay, so the first thing we need to do is group. Now, here we're going to use the group operator in this first stage of our aggregation pipeline. And the way we're going to group is based on a user's screen name. Let's briefly go back and take a look at the data. Remember that all of our tweets have a user field, and that user field is actually a nested document that contains a screen name. Okay, so if we go back to our aggregation query, we can see that we're saying for the user subdocument, I want the screen name field. Okay, so what's this about? Well, this isn't an operator. Instead, what this means is, even though it's inside quotes, don't interpret this as a string. That is to say, don't make the ID user.screen_name. Rather, group together all documents where the value of screen name for the user subdocument, that's what this dollar says should happen here, where the value of this is the same. So all tweets that have this, the same value for this field, will be grouped together. And then we need an accumulator of some kind. There are a number of different accumulator operators that we can use. What this means is, for every document that has the same value for this field, increment this value count by 1. That's the semantics of this. So this accomplishes those first two steps that we talked about here. Group tweets by user and count each user's tweets. Then the next thing that's going to happen is we'll simply do a sort. And this says sort based on the count of the documents that are passed into this stage and sort into descending order. Okay, what do I mean by the documents passed into this stage? Well, the reason why this is called a pipeline is because each stage receives a set of input documents and produces a set of output documents. And we'll talk a little bit more about that later. The input documents to the stage that uses this sort operator are the documents output by the stage that uses the group operator. So what we end up with for this stage is a bunch of documents that have an _ID field and a count field. And this stage of the pipeline is going to sort those documents based on the value of their count field. Okay, now, if you didn't catch all that, don't worry about it, because we are going to dive into all the bits and pieces here as we move through this lesson. Let's go ahead and run this code and see what it produces. Now, I'm simply going to pipe this to the system program less so that I can see the very top of the results that are produced. Okay, the results from an aggregation query are always a single document. It is the result field of that return document that we're interested in. And here we can see that what was outputted are exactly the documents that were passed to the sort stage of our aggregation query. They each have an _ID field and a count associated with them, and they've been sorted into descending order. Now, note that there's only 8, or rather that the maximum number of tweets for an individual user is 8. Okay? This data set is a snapshot from a relatively short period of time. So that's why these counts are fairly small. As we move through this lesson, we'll take a closer look at the aggregation pipeline, at what it means to have stages within that pipeline, and at the various aggregation operators that are available to us, as well as other operators, such as accumulator operators, that we can use in the group stage, and other sorts of operators we use elsewhere in aggregation queries.